Okay. Intro to logs part two, people. Here we go. So here we're comparing transformation of a log. Remember that every family of functions has a parent function, and the parent for logs, just like the parent for exponentials is 2 to the x, is log base 2 of x. So this is a version of that that's been manipulated. So to do that, I created this and embedded this little Desmos graph to see how they've been changed or manipulated, and we'll come back to that as we need to. But here it is. This is the graph that we're talking about right here. This is y equals log base 2 of x plus 3 minus 1. The key to answering part A, what transformations are performed in what order, are, remember this little graphic we've used all year, that stuff happening inside the function itself, in this case inside the parentheses, is the opposite of what you would think, and stuff happening outside is the same and it's vertical as opposed to inside being horizontal stuff. So, and then when it says in the appropriate order, that's where we got to think about PEMDAS. In other words, when you input an x and actually do the math, what happens first? So 1, if we were to input an x, we would add 3 first. So that part is happening first, the inside part is happening first. So it's getting shifted 3 units to the left before it's being shifted 1 unit down. So if everything's being shifted 3 units to the left, that vertical asymptote, that wall that was originally the y-axis, is going to get shifted 3 units to the left as well. And that's what we'll never cross. Well, that's the line x equals -3, as opposed to this being the line x equals 0. So, and then our domain, okay, well, the domain was x is greater than 0. In other words, everything beyond 0, moving forward to the right. So now our domain is x is greater than -3. It's important to note, even though they didn't ask it, that the range hasn't changed. That's still all real numbers. Still going down forever and up forever. Okay, now we have a new function here. Determine the function, the domain of the function y equals log base 2 of 3x minus 4. And they're giving you this hint. This will always work. If you need to come up with the domain for a log function, just grab the inside, the part that we're actually calculating the log of, and set it greater than 0. Again, because we're trying to just essentially find the value that we can't be, to find the values that x can be, which is the domain. So I'm just going to solve this. And that will be our domain. In other words, that this graph will never cross over the line x equals 4/3. And I'll show you a visual of that I made as well. And there you go, there's the function. And as you can see, you can get closer and closer, but never actually touch. And that's the concept of an asymptote. Okay, moving on. Page 27, example 54. Remember, a logarithm essentially gives as its output the exponent we have to raise in order to get the input. So I always just kind of simplify that to say the answer to a log is the exponent. So for example, if I said 5 to the what power equals 25, you'd immediately say, oh, 5 to the second power If we replace that question mark with a variable and say, okay, what would go there? Well, then you could say that x would equal 2. 5 to the second power is 25. So essentially, that's all we're doing. And if you look at it, we're essentially just kind of switching. And this is where these get kind of quick and fun. Here the answer is 3 because 2 to the third power, and that's tough to squeeze in there. Sorry about that. But let's see if we can get a 3 in there. That's not bad. 2 to the third power is 8. So the answer to log base 2 of 8 is, hey, what is the power we have to raise 2 to get 8? In other words, if you want 8, it's 2 to the third power. So the answer is 2. The answer is 3. The log is 3. So here we go. I'm just going to bring down that 4, put a variable here, and say, okay, switch these babies around. What's the power I have to raise 4 to get 16? And that would be 2, or to the second power is 16. Do the same here. Bring your base down. Remember, in this case, 6 is the base. Put a variable here and say, okay, what power do I have to raise 6 to get 1? Well, this is that old property that anything to the 0 power is 1. So in this case, x would be 0. Again, bring the base down. Put in a variable, perform the old switcheroo. All right, 6 to the x power is 1/6. Okay, well, we get fractions, we get stuff in the denominator with negative exponents, and the 6 is unchanged. It's like 6 to the first power, so this would be 6 to the negative first power is 1/6. Again, bring down the base, insert a variable, switcheroo, 6 to the x power equals 1/36. Well, 6 to the second power is 36, so this is just 6 to the negative second power. And then lastly, bring down your base, and you've got 6 to the x, 6 to the what power is the square root of 6. Well, don't forget that radicals can be written with fractional exponents, rational fractional, radical fractional, and that the radical, the square root without a root shown, an index shown, the default is 2. And so we're just going to say, all right, that's 6 to the 1/2 power. Hey, look at that. Since the bases are equal, then the exponents have to be equal. So x is 1/2. Moving on to using a calculator to do logs, especially old scientific calculators. The base could be anything. So the default is 10, and that has to do with the fact that our decimal system, our number system, is based on powers of 10, that we have the ones place, the tens place, the hundreds place, the thousands place, and the reverse in the decimal direction. So we call this the common log. 10 is the common log. In other words, like I just mentioned up here, when a 2 is not shown, when the root is not shown, it's a 2. Well, here, when the log is not shown, it's a 10. So all three of these, even though they don't show one, they're 10s. So let's begin by putting those in. Log base 10, log base 10. That one's a little weird looking, so we'll rewrite that one in a moment. And then we're just going to go, okay, so if the base is 10, bring down the base. We want to know what the power is that you have to raise 10 to get 100. Well, that one's obvious. That one's 2. X to the second power. Sorry, 10 to the second power is 100. Here, let's just rewrite this a little neater. Log base 10 of 1/1000th equals x. Bring down your base. Switcheroo. 10 to the x is 1/1000th. Well, 10 to the third power is 1,000, so this must just be 10 to the negative third power. So x is -3. And then lastly, bring down your base, insert your variable, switcheroo, 10 to the x equals 10. Oh, well, anything to the first power is itself, so x would just be 1. And that'll do it for us today. That's solving logarithmic equations. Miss you guys. Hope all's well. Keep in touch and take care of yourselves. Over and out.